Hello friends, today we are going to discuss about the problem that sum of all the digits of a given number. Okay, so let's understand the problem statement. Suppose we are given an input number like 299 and I would like to get sum of all the digits. So what are the digits like 2, 9 and 9? So we would like to get sum of all these digits, which is nothing but 29 here. And we have another number like 1 2 3 4, and we will get sum of all its digits like 1 2 3 and 4, and it is nothing but 10. 4 plus 3 plus 2 plus 1, right? So it is 10. So how we can achieve the sum of these digits? So in Java, so we have two very important operators which do help us in this regards. One is modulus operator and other one is divisor operator. So this is what we see in keyboard as percentage and what we see as a divide. So what these operator do, so if I perform modulus on 299 with say digit 10, so it would give me remainder of when say 299 modulus 10, it would return us a remainder. So here remainder is 9, and if I say 299 divided by 10, so it will be fully divided till 290, so it would give us 29 in this case, right? So these two operators would help us to solve this particular problem. And I would like to mention these two operators has lots of applications in number system, especially in our number system problem solving. Like if I say few examples, like suppose we like to transform one number decimal system to binary or octa or hexa. So there these are the again two operator plays a crucial role. So let's understand this concept and it would be quite useful going forward. Okay, so let's come back to the problem statement. So I am performing two operation on it like modulus operators and divisor operation. So when I performing modulus, we are getting the quotient or remainder back, and when we are performing divide 299 divide 10, so we are getting our number back. So again, so if I get a 9, so let's start performing our sum also, like so we get 9 here after one set of operation, and we would keep on performing this operation like modulus operation and divide operator till we perform this till we reach 0, that we have nothing left, no digit is left to perform any other operation on it. So let's again divide modulus operators like 29 modulus 10, right? So if I perform this again, I will get 9 back. So let's perform addition here, 9 plus 9 here. Okay, so let's perform 9 plus 9 here. Now if I say 29 divided by 10, again the same like 299 we divided by 10, now 29 divided by 10, right? So we will get 2 back in this case, right? If I say 29 by 10, had it been 30 then it would be 3, but it is less than 30 and more than 20, and so that's why it will reduce to 2. Okay, so again perform same two operations like modulus operation and divisor operation. So 2 modulo 10, right? So it would be nothing but 2, right? So again perform sum of 2 here. Okay, and now perform 2 divided by 10. So as it is less than 10, it will be reduced to 0. So as it has been reduced to 0, so we don't wish to perform any other operation. So because we got all our digits which we are looking for, so we have to keep on performing till uh, we are getting a number as 0, the input number as 0, right? So this 3 digits which we perform, which is nothing but 20, like what we see here, 9, 9 and 2, right? So crux is that given an input number, so what we do, we perform 2 operation on top of it, like we perform modulo operators, and then we perform divisor operator. 2 operation we perform. So once we get an remainder back, and then the number gets reduced proportionally, so it will become, first it will become 29 and then it will become 2, right? So this is the whole idea. So similar operation we can perform on 1 2 3 4, and same thing we will get it back. So let's do it again. Let's briefly touch uh, that particular number as well. Okay, so we have an input number like 1 2 3 4. So what we would like to do, we like to perform 2 operation again on top of it, like modulus operation, modulus 10, right? So we'll quickly go through it. So it will give us 4 back, and then we perform 1 2 3 4 divided by 10. It will give us 1 2 3. Okay, so let's keep on adding the digits as well. Okay, now again perform modulus operation on it, like 123 modulus 10, right? So what it will give us, it will give us 3 back, right? So let's put 3 here. Okay, so then we perform divide on top of it, so modulo 10, right? So it will give me 20, 1 2, right? So again we'll keep on performing the operation, so we'll get 2 back, and then consequently we get 1 back, right? So it is on the similar ground what we see. So that is the only thing. So 3 things we have to look up now. So we have to divide it, one we have to perform modulus operation, then we have to divide it, right? we have, right? So, and then we have to keep on performing the operation till we get 0, right? So we'll take these 3 pointer, and let's go to our program editor, and let's write our program there, and then we see what is the output, right? So idea is, we have to perform these operations like modulus and divisor operation, and then we have to get the sum of all the digits. So let's write our program there now. Okay, now this is our editor. I brought to my editor. So let's create a class, say sum of numbers. Okay, so let me write an method. So let's say private static method which return sum of all the digits, and I have an input which is number. Okay, so let's declare a variable sum of all digits. So let's initialize it with 0. Okay, so as we discussed in our demonstration, so first we divide number with modulus operation we perform with 10, so it would return us remainder back. Okay, so for a time being, let's store it in a remainder. Okay, and then what we do, we say we divide it by 10 again, so that we reduce our number correspondingly, because we get 1 digit back. So let's write our input as well, 299, right? So that we can correlate. So first time remainder, it will give us 9 back, and then let's divide the number by 10. So we get 9 here, and then number we get 299 by 10, so number will be now 29. Okay, and we have discussed that we will keep on performing this operation till our number is become 0 or less than 0, right? So it will obviously become 0, so if we keep on performing this operation, so we write a loop till number is greater than 0. Okay, Now the remainder, right? So remainder is nothing but we can store it in our sum variable. So let's, instead of initializing to remainder, so let's store it in our sum. So let's keep on adding to our sum of digits all the time. We can, initially it would be 0 first time when I am getting 9, so sum would have 9. So then number we are divided by 10, so it would become 29 after first iteration, right? Number would be updated 29, right? And now next time if we go, the number is 29 as in the last iteration we have seen, right? So number is 29, then it got divided by percentage of 10 we have taken, right? So again we get 9, right, in that case. And then we divide 29 by 10, this number become uh, this number become 2. It is a similar thing which we have seen in our demonstration, nothing special here. So I am just doing the dry run so that we can correlate it. So then number become 2, right? So then number percentage 2, it would get returned 2, and again we added this to the same number, and then we divided that by 10, then it becomes 0. So this is nothing but the again the same demonstration which we have just seen few minutes back. So I'm just removing rest of the numbers. So once this while loop is over, we just return the number back. So let's say sum of all the digits number, it will have sum with us. Okay, let's invoke our program from main and let's see what will be the output. Okay, so let's declare an input number which would be, let's say, 299. Okay, now let's print what we are uh, giving as an input, and what would be our output in that case. So let's write that as well. Input is this. Let's invoke our number. Let's invoke our function and passing input there. So this guy will invoke this method, then it performs this operation and returns the int back, and then we are just printing it. Okay, so let's run our program to see what would be our output in this case. Okay, so let's see. So we can see that input is 299 and we can see an output of 20. So let's take another number, as we have seen in our demonstration. So let's copy paste it. Okay, so the another number which we have taken was 1234, right? So let's again run this program and see the output for second case as well. Right, for first case it is 20, for input is 299, output is 20. For second case 1234, output is 10, right? So this is the whole program. So let's briefly discuss it again. So whatever we've done, so we have given input number and we are iterating the number till this number is greater than 0, because once it is reached 0, there is no point of performing modulo or the divisor operation on it. So first time we get remainder and then we store it in our sum variable, and then we divide the number by 10 so that we get rest of the digits. So in our example of again 299, first time we get the remainders, then we divide it by 10, so the output it become 29. So number will be updated to 29, right? So then next time when we come, so 29 modulo 10, it will give us again 9. So again it gets added here, then we divide it again by 10. So it is the same operations. We keep on performing this operation till it is greater than 0. So, and I will again reiterating, so this is very important concept, these two operators like modulus operators and divisor operator. So we should understand this, that is nothing but quotient and divisor operator, which we generally study in our schools, right? So, and they have very numerous applications when we perform in our number systems. So we will upload some video going forward, and then we do mention about this particular video, right? So that's it for the today. So thanks a lot for your time. Have a great day ahead, and bye bye.